So 7 was part of the homework, and there's going to be a lot of things going on here with this question. So let's go to 7, and you have cards with the numbers 1 to 5 on them. Okay, so there's a lot of that little statement actually tells us right off the bat that there are no repeats allowed. And another way of looking at it is you have a limited supply. Okay, so it's not just like you're allowed to use numbers 1 to 5 for the following. It's saying, hey, you have cards numbered 1 to 5. That's all you have. So if you take from them to create your digit, you're left with 4, right? And then 3 and so forth. So how many different 3-digit numbers? So, right, you've got 3 options, or you have 3 slots to fill, I should say, can you make with these cards? So here we go, event number 1, event number 2, and event number 3. So that's the 3 digits, right? You've got 3 slots to fill. And numbers 1 to 5, you've got 5 options. So it's 5, 4, 3, and that's it. So 5 times 4 times 3, you've got 60 digits possible. Okay, that's how you figure that out. You could do a tree diagram, but you wouldn't want to do that, right? It would be pretty crazy to make a tree diagram. I did show you a tree diagram, but right now we're just going to go with it. Okay, all right, so let's keep going. This is where I add complexities and I add layers to this. Okay, how many different even, that's a restriction there. How many even 3-digit numbers can you make using these cards? Okay, and I'm going to split this into cases. I don't know which key I posted, because I've gone through this a bunch of times, so I don't know which one I scanned to post, but I'm going to say it this way. Technically, you would start off like, okay, you've got 3 spots here, but this is the first, you got to meet this first. Meet first. That is where I would start. It's like, I got to make sure that happens. And how does that happen? How does a number turn even in this case? It has to end in a 2, or it has to end in a 4. Those are your 2 options there. I will show you, I think the key, did I split this into cases and on my key? I feel like I did. So I'll show you both ways. Okay. I think I'm gonna, so you have, I'm gonna go, instead of comma, let's go or for now, because you're still, this is very new, right? So 2 or 4 must end, must be, okay? Must be 2 or 4. That's what you're coming up with. So in that case, I would split it into 2. Option 1. Later on, I'm going to just give you a shortcut. But for now, I'm going to go option 2. So I've got my 3-digit code. I'm going to look at all the codes that end in a 2. And I'm going to consider all the codes that end with a 4. Like, there must be a 2 in there. So technically, there's only one option to meet that requirement. You do that first. It has to end with a 2. If you're taking the 2 out, guys, if that 2 is out, how many options do you have left? Well, you've got 4 to fill the first space and 3 to fill the second. Right? You kind of start here. I'll say start here, and then you figure out 4, 3. Okay, does that make sense? I know it's Wednesday morning. You're like, okay, next. Or, so option, can I add the or here? Like it's this or that. I have to consider both possibilities. If everything ends in a 4, if I'm considering, then there's just one choice for that. Right? And then I, again, go 4 times 3 times 1. So 4 times 3, I think we all know that's 12. Same here, 4 times 3, that's 12. So I have 12 in each category. 12 numbers that would be even here, and there are 12 numbers that would be even under the second circumstance if it ends with a 4. That combined gives me, right, if I add that, 24 possible digits that would meet the requirement. Okay. So watch this, guys. Out of the 60 digits that are possible in total, this is like my universal set here. I've got 24 of them would be even. Okay. Start thinking about it that way. This is the universal. Here I've created like 2 sets, right? And I have stuff in there. Morning. Page 7. All right. Next. How many different 3-digit numbers that are greater? So 3 digits is like the theme here, by the way, are greater than 300. Can you make using these cards? All right. So let's do the 3. 1, 2, 3. So if this number is greater than 300, let me just think here. Maybe you think too. If it's greater than 300, can I have 3 or 4 or 5? Like remember, we've got 1 to 5. Can I have the 3 there? I had to think, you know why? Because I was thinking, what if it's exactly 300? Right, then it's not greater than 300, right? So then there's a problem. But I look back at my cards. Look back at the cards. What are your options? 1 to 5, right? 0 is not in there, right? Scratch, right? So you can use 3 or 4 or 5. You can. Because you'll never have to deal with a 0 at the end here or having 0, 0. You won't have to worry about that. You know what I mean? That's why I had to think, do I include the 3 or not? Is it just 4 or 5? Or is it 3 as well? And it ends up that 3 is also an option because, right, you could have 3, 2, 1, or anything that follows would not be 0. So I don't have to worry about being exactly 3. So if I have a 3, a 4, or a 5 in the front, this will be met regardless, given the options that I have. Okay? So instead of doing it this way, I will show you the 3 options here. Option 1, option 2, option 3. Dun, 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 so we've got a 3-digit number there, a 3-digit number there, a 3-digit number there. I'll show you that this can be done a lot quicker. Okay, so you either have a 3 in the front, a 4 in the front, or a 5 in the front. In each case, there's just one option, right? You're narrowing it down to just one option. Times. If you've used up the 3, right? You're with me here on the first one, right? If you used up the 3, how many options do you have left for the rest? You've got 4 and 3, correct? Let's go back and start option 2. The same thing applies. Let's go back to option 3. If you've used the 5, you've still got 4 here, and you've got 3 there. So 4 times 3 is 12, 12, 12. So all combined, you've got 36 possible digits that can be created using these cards that are going to be greater than 300. This is the long way. I will show you the short way. You ready? It's basically saying, well, how many options do you have to fill the first spot here? You've got 3, correct? 3 options to fill the first spot. Regardless of which one you pick, either you pick that one or that one or that one, right? Because you can only pick one at a time. You would still have 4 times 3 left. Like if you pick the 3, you'd still have 4 for the second spot, 3 for the third spot. Okay, so what's 3 times 4? That's 12. Times 3 is 36. So this is the shortcut, short version, long version. They both give you the same 36 options. This one is just a little tricky because some students would say this. Pay close attention. Oh, I grabbed 3, right? I grabbed 3 cards, so I have 2 and 1 left. That's what some students would think if they see this part. Okay, but I'm not saying that I'm grabbing 3 cards. I'm just saying there are 3 options to fill this one. So regardless of which one you choose, boom, it's gone, right? So then you have 4 and 3 left for the other 2 spots. Scratch, scratch. That's okay. If your head is kind of hurting, it's okay. All right, we're gonna do a bunch of these. So, okay, guys, you have the option to do this, or you have the option to do it this way. Okay, there we go. You know what? I can tell you this: if 0 had been in the mix, 0 would have caused us a bit of trouble. Why? Because can a number start with a 0? No, that would no longer be considered a digit, right? So I won't get there right now. I'll just continue. All right. We'll do different math yet today. So we'll do a bit more here. How many three-digit even numbers? Even numbers. That's my first restriction. That are greater than 300 can you make? I wonder if I'm going to leave this one for now because this is going a little beyond, but maybe I'll do this. Yeah. Watch this. I'm going to set it up first and then I'm going to solve. If you want even numbers, guys, what does it have to end with out of the options that I have? 2 or 4. Right? For the even part, what about the greater than 300 part? That's when I focus on the front, right? I have to have a 3, a 4, or a 5, correct? Is there going to be a problem here? You see that there's a conflict? Look at the options in the back and the options in the front. You see the 4? There's going to be a problem there. There's a conflict. I'll say this. There is a conflict between restrictions. This one I would tell you already off the bat. This one is higher in terms of difficulty, right? This one is on the higher scale. So what do I have to do here? I have to break this into options again. Option 1. I'm going to say, well, I will consider the case where I just take into consideration the numbers that end with a 2, which means you only have one option. And that should happen first. You always you want to make sure it's even, right? They all have to be even. So first restriction. This has to happen first. Then we go, well, what are my options in the front? Like to be greater than 500 would be what? 3, 4, 5, right? It could be 3 or 4 or 5. Are any of these in conflict with the 2 in the back here? And the answer is no. There's no conflict, right? So I have 3 options here. I'll give you $100 if you give, no, I'm just kidding. I don't have $100. what would you put in the middle here? You would put a 1. Remember what I said about the 3 up here? You've got 3 options, but you're only grabbing 1 at any given moment. There'd be a 3. Okay, and I know this is, follow my train of thought. You grab a card, the 2, right, is gone. So now you're down to 4, correct? You grab another card, now you're down to 3. So this has to be a 3. And how in the world do I do this in notes, right? Like, how do I make sure? I think for now I'm just going to leave it. It's going to get too messy, but this is card number 1, gone. Card number 2, gone. You've got 3 options, but you're only grabbing 1 at a time. That means you have 3 left, 3 cards left. I'll try this, hold on. Card number 1, card number 2, and then there's 3 left. 3 left. Should I say 3 cards? Otherwise, you're going to say number 3 is left. 3 cards left. Now you've got the other option. Option 2. 10, 10, 10. We're now going to consider where it ends in a 4. And there's obviously then, that means that you only have one choice there. It has to be a 4. Right, so I'm just narrowing it down to just one line. But technically this would be like this. There would be 3 different branches there. But just be too much work. But if you wanted to, you can go for it.
But it would still come to the same conclusion.
It would still come to the same conclusion.
You're just kind of compressing it as well.
Yes. Let's go with, I'm just dealing, guys, I'm dealing with this, that there's an overlap between the restrictions, okay? And I'll tell you already, this is like the highest, probably the highest difficulty where 2 things overlap. And so this would be like a C or a D in a question where I kind of set it up already, okay? So if I grab a 4, this has to happen first, okay? First thing that happens. Then I go to the front for the second. Do I have 3, 4, or 5? Do I have all 3 of those available to me? No, this one is gone. I cannot use 4 in that case. So how many options do I have? 2. Yes. How many cards are left? You grab one, you grab another one, so you're still left with 3 cards. 3 cards left. Okay? So let's do the math here. Both of them. 3 times 3 times 1, that's 9, correct? 2 times 3, that's 6, times 1 is just 6. So let's combine them. There's 15. 15 digits. This is basically the one you want to circle. This is like your ultimate. Guys, let's think about this. If your answer was like greater than 60 or 60, that should be an alarm. I did something wrong. You're like, why, Mr. Dirksen, why 60? Why did you come up with 60? What's the very first one I got you to do here? What are all your possibilities here? 60, right? If you had no restrictions whatsoever, you would have a maximum of 60 digits possible. Now I'm narrowing, you know when you filter things, when you look for things and you filter, right? I don't know if you ever searched like that, but I use filters all the time. when I go shopping, right? Filter by price, and then filter by brand, right? You're narrowing it down. So every time I add a layer of restrictions, it should always be less than 60 in this case. Okay, should always be less than 60. All right. Um, so basically, what I'm saying is, if you did all right with page 6, you're doing pretty good right now. Okay, so I'm just taking it further. Let's skip E for now. I'll skip for now because it's the same idea as the D. Um, how many ways can the letters in the word pre-cal be arranged? And note, there's a limited supply again, right? Like you only have what's in that word, right? Those are the only letters that are available to you. And this is how you do it. How many spots are there? 1, 2, 3, 4, 5, 6. Right? So 1, 2, 3, 4, 5, 6. You're saying if I'm using all of the letters in there, like how can you like rearrange them to make a different word? Okay? And the answer is 6 times 5 times 4 times 3 times 2 times 1. That's 720 ways, by the way. This is going to be a theme. If this ever shows up, a word like this, that's going to be your go-to. Just count, right? I will just make a note here. 6 letters. Six letters, so I just go ahead and go 6 times 4 times 3. So that's how you come up with new words. All right. One more on page 8. So some of these are classic. I call them classic questions. Classic. There are 3 roads from Arborg to Brandon, 5 roads from Brandon to Carmen. If you cannot travel the same road twice, how many ways can somebody travel from Arborg to Carmen? So Arborg to Brandon to Carmen. So what this is saying is there are 3 roads connecting Arborg to Brandon. There are 5 roads, 1, 2, 3, 4, 5 roads connecting Brandon to Carmen. Right? So 3 and 5. So how many ways can you travel from here to there? Right? And the answer is you've got 3 options to go from A to B. You've got 5 options to go from B to C. So there are 15 ways. That's if you don't double up, right? So if they had like a 4th town, you would just multiply the roads connecting C to that 4th town. And there you have it. Dauphin. Maybe we could use Dauphin, right? Add Dauphin to it. And so don't be surprised if it's 1. If there's just 1 road from Carmen to Dauphin, it'd be 3 times 5 times 1, which is still 15. But there's only 15 unique ways to get there. Okay. Can I add that to your notes? 15 unique ways. I would have to add that, right? It's very important. It's not just 15 whichever way you want. It's like unique. So if you went on the first road here and the first, that's 1 unique way. First and the second, that's another unique. First and the third, first and the fifth. And then you go to the next one. You take this one and the first, and so forth. Like that's really what you're figuring out here. So it's a lot quicker than counting. Can you imagine counting? If I added more options, it's just too much time. So this is what you want to start doing here. This would be the event. Let's zoom in even more. Event number 1, You're going from A to B. The second event that would happen is going from B to C. Okay. This is supposed to be an arrow, by the way. You're going from B to C on the second event. So that's really what I'm doing here. I'm still using the counting principles you learned earlier. Okay. All right. And now we will talk about factorials. And you're like, what? Yeah, it's brand new. You've never seen it before. If you've been in pre-cal for a bit, maybe. Other than that, no. Okay. Yeah, go ahead. So page 9, I will start in a bit. I'll just get my attendance all good to go here.